Okay, welcome back. Hello again. What I want to look at today is single-phase alternating current series circuits. Okay. So what I want to mainly do is to look at this as an ongoing process. Now I've provided here with just some unit symbols, okay, quantity and unit abbreviations. Now these are only a sample. You will need to look up anything additional in your on the online or on the net, or look at the information you can have in your on-site guide or any booklets that you may use. Okay. Now again here, just remember that this is just an example, okay, of the SI units, as I've just said previously. Now alternating current in a circuit consisting of resistance, inductance and capacitance in series. This is shown below in the diagram 1.1. Now draw out the diagrams. Don't assume that you will know it offhand. It is not a guessing game. You must draw out the diagrams. Okay? Okay. Three types of conditions, okay, which exist, etc. And these conditions are there for you to see. Again, write out those conditions, make them your own. The information you will need. Okay. Now be aware of the phasor diagram. It is only indicative at this point in time. The phasor diagram, when you've done a calculations, can be drawn out in respect to the given values of voltages which you have measured and calculated. Okay. Now reminder of the following points previously mentioned. Okay, purely read the points. Okay, and I've just made a point here that the phasor at this stage is not to scale. Okay. Now again here, you can read this for yourselves, etc. Okay. Is the impedance. Now remember that in AC circuits, you see the current flowing sees impedance. Okay. And all I've done here is show you those diagrams as such. Okay. Now I've gone ahead to show you how the Z squared equals R squared plus XL minus XC squared. Okay. And how that has been arrived at. Write out the information. Look at the additional information for yourself. Become aware as to how these are achieved and they are calculated. Okay, let us look on. Okay, let's look at an example. Now, run on to done an example here. Now, write out the question in regards to the example given. Do not try to read it off the screen. You need to make that information your own. Be familiar with the process of actually writing it out, because when you write something out, your brain does not forget. Okay, and I'm just going on now with the values here. This means etc. You can see L equals 0.2 Henrys, etc., etc. Okay. Now you should be able to slow this down for yourselves when you come to view this, okay, and make it applicable to yourselves. One of the things is that my camera seems to be running low on battery at a point in time, at the most inopportune moments, but nonetheless I will continue, okay. Now here we need to find the current, and you've seen what I've done here. I equals V over Z, okay. Let me just bring you in here, we made a little note, so look at the notes, okay. Okay. Again here, and we're now finding the potential difference across the various elements of the circuit. And if you go back, you will see that the voltage across the inductance is very high. It's higher than the supply voltage. So keep that in mind, that when you're dealing with inductive and capacitive circuits, the voltages can be very, very high. Now here is the angle, okay, so we'll simply look at the angle in regards to cos, and we get that 0.3069. You'll need to put that into your calculator, because then it gives you the actual phase angle, okay. Now, I've drawn the Phasor diagram, okay. You guys might be able to do it a bit more accurate than myself, but you'll see that here the voltages actually does work out to be reasonably correct. Okay. Okay. Now I'm hoping that you can see that in the red highlighted section. Okay. Voltage triangle, and another one here giving you the voltage triangle. Again, this is not to scale. Okay. but then I've gone on to give explanation as to why, what I tried to have a look at and see whether or not it was possible to bring this to scale. It is, but I was still left with the mathematical process of calculations in this case. An impedance triangle. Okay, now again here I'm going to give an explanation. I did a little research myself to make sure that the information I was given was as accurate as possible. Okay. Now this angle here is only for example purpose only. It does not relate to the actual calculations of the circuit we have done previously. Okay, purely as an example. Now I've then gone on to do a few maths, and I've put some maths in here because some people still have problem with maths, and it's just to give you an idea as to what you're able to do. I've also provided you with the answers, so you don't need to be wondering what the answers were. Okay, but please try to do the questions before you look at the answers. Okay, and here is where we're at. Okay, and I would just like to say thank you for your time. Okay, I hope you find this useful. Okay, I will try to make sure that I enhance the video once I have uploaded it, and that it is useful to yourselves. Okay, anyway, have a good day for now. Terence Payne signing off. Thank you.